Sorry that I can't be in class this evening. I know it's our first week, and I'll do my best to get through this. And I do appreciate your understanding. Um, anyway, so where I left off was to start here today with is the Azure architecture, and then getting into resources, and then I was going to go ahead and go into your next lab in the Pearson lab access that you have for the AZ900 course. All right, so there's different layers to our architectural styles for Azure. So the one that's more traditional is called the N-tier architecture. And this is, these will be on your AZ 900 exam, I'm pretty sure, or related to it. So in our enterprise, as I mentioned to you before, we always talk about things with an enterprise concept in mind, because that's what we're talking about as far as networking and using Azure in these environments. So because it's very traditional, you'll notice that you'll see in the diagram here, it follows the kind of traditional way we do things in a network. We have our client, we have our web tier, we have our messaging, middle tiers, our cache, the cache stores the information so you don't have to keep going all the time and having a new search or a new query all the time. And you have remote services, and then you have your data level tier. And that's kind of the down and dirty. So the application is going to be divided into layers, and we're used to working with layers in networking because of our open systems interconnect model, which is the OSI model. And you can either look at the 7-layer system, or you can look at the 5-layer or 4-layer from TCP/IP. That's transport control protocol with internet protocol addressing. And I'm kind of jumping a little bit forward here, but just to give you an idea, we like to use the layering. We do layers, and each of these layers perform what's called logical functions. Like when we look at logic in business, right? We look at different management and the different layers of management and the different areas of a particular business and what we're going to do. But again, the reliability here is it's all one layer. It's like horizontal. So if we want to make any changes in any part of that application, we have to make the changes in all the other parts of the application too. So you can't just do a little bit here and do a little bit there. It's across the board. So that's where your challenges come when we talk about updates. It's not as easy to do. New features cannot be easily added. So if you want something that's more the traditional way and you're not going to have a lot of changes that you need to do, then the N-tier architecture would be the way to go, the basic type traditional system. And I'm not going to play the videos here. I'm going to let you go back and play them. So please go back, because when I create my presentations, I go and I locate what I think are good videos to guide you. So what I'm telling you is one thing, but to kind of help you, drive it home, so to speak. So please go back and watch those videos. They're going to help you. Now, the next one you have is called the Web Queue Worker, WQW architecture, Web Queue Worker. Now, this is from your front end. When you think of programming, we have a back end and we have what's called the front end. And the front end is going to handle all your HTTP, and it should be HTTPS requests. And then the back end is just think of backbone in the network. And then we have all our devices, that we're utilizing throughout the network, but you have an infrastructure, a backbone that helps connect everybody. Well, it's the same thing here. We have a front end that customer faces to you on a website, right? That you're looking at, okay, such and such. But the back end is doing all of the operating for you. And it's very central processing unit oriented, extremely intensive when it comes to CPU. So say an asynchronous message is queued, right? And it's used for communication between the front and the back. So this makes it easier and is much more suitable when you have simpler tasks that are based on these types of resources. Okay, so you see here's our client, the identity provider, here's our web front end, our content, right? Queuing, worker, cache, because the cache stores that information, so you have to go grab it every time. So you could have static content, and then for remote services and your database, which gives everybody what they need within a specific time. But again, very simple tasks that are based on particular resources you have from your web, right? Whatever you're going to do from front end and back end. Now, the next one is called microservices. So this is a lot of small but yet independent services constitute what is called the microservices architecture. We're talking about single business. We're not talking about, like we have a campus, right? But we have a lot of remote outreach centers or other campuses. Not the best idea when it comes to Azure and doing this. But a single business capacity, again, is implemented by each service. So the services communicate through the contracts of your API, your application programming interface. So a focused team can then build on that service. You can customize that service as needed. But the coordination has to be among the teams to build the services and then do those updates. So it's not a real simplistic architecture. It becomes more complex. So you'll see here we've got our, our client identity provider. We've got our content. Here's our gateway to all the different microservices that we might have to offer, and then managing them and then providing other service discovery, and then giving remote service access as well. So again, these are things that you have to think about if you needed to offer certain services. That's why they call them microservices. You could have a number of them, but remember, when you go to update or you go to check on things, you have to be really cognizant of it, and you don't want to miss anything because you don't want to leave yourself vulnerable to any type of security flaws, that anybody could get in and wreak havoc. So you have to take those into consideration. And again, I have a video on microservices and message queuing. So they kind of go together. Then you have what's called the command and query responsibility segregation architecture. A lot of long acronyms here. This is the reading and writing, right? So the command and then the querying. So the operations of reading and writing get put into two different types of models, right? And as a result, the part of the system that writes the data, and the data is separated by the part of the system that reads the data. So writing the data, reading the data, right? Also, the write operation is performed in what's known as a separate database, and the read operation is performed against that materialized view of that database. So this helps when you're performing read and write operations independently. And the materialized view can then be optimized for any of the queries that are going to be made. So a client, command model writing, and there's going to be an event, it gets updated, and then that updating or that information gets materialized so that then you can read what's the most current that's available upon that query when you go to ask for something to be able to see it. And also, I always make sure, like I said, always got a video to go with it to explain it to you in further detail. Then you have what's known as event-driven, and these are the ones I'm more used to, is the event-driven architecture, which follows a published subscription model, also known as what's called the pub-sub, published subscription model. This is where the events are published by whoever's producing it, and then those that want to go get what's been produced are subscribing to that. So think about it as we used to have DirecTV in our house, and we don't use DirecTV anymore. I decided to finally go to streaming. I wasn't totally convinced, but once I found streaming was better, and then I got AT&T fiber in the house, and it didn't have so much buffering with everything, I decided to go full stream and got rid of DirecTV. Now, in doing so, okay, think about it this way. We've got Sling, we've got Hulu, we've got Apple TV, we've got Paramount Plus, we've got Disney Plus, we've got Acorn, BritBox, Amazon Prime. I still use Sling. So you've got, like we're showing you here, producers and consumers are independent of each other. You can have many of them. I can go and choose who I want. I have a number of them that I subscribe to, which is still less than me paying DirecTV. So I can have all of those channels that I want to subscribe to. Well, it kind of follows the same way here. The producers and the consumers are independent of each other, and the consumers are independent of each other. I mean, the consumers don't see each other either. So for example, when you look at the Internet of Things, right, the Internet of Things solutions, which processes a very large volume of data, it has very low latency because the Internet of Things devices run mainly off of sensors. Sensors don't take up a lot. They're very low powered, right? And then this event-driven architecture becomes very useful. It gives us a lot more choice. variety. So this is what I'm used to here. So you have event producers, then you have your event ingestion, and then whoever your consumers are going to be. And you can have a number of producers and you can have a number of consumers. But this is what it looks like when you're looking at event-driven architecture. There's also big data. Now, big data has become a very big deal over these last few years. You'll see big data. You'll see the terms big data, or what's known as big computer architecture. Now, I don't necessarily use it, and I hadn't when I was still at UF because big data wasn't there yet. So some profiles will fit only particular types of architectures. And this is one of them. One such architecture is big data, or what's called big computer architecture, which is special into fitting profiles into certain types. So a very huge, and we're talking a very vast, large data set, can then be divided into what are known as chunks for processing data in parallel so that we can go and break it down and make raw reports and analyze from this information. It's also known, as you might have heard this term, as opposed to big data or big computer architecture, as high performance computing, HPC. People heard of big data, but they don't know what that means. So you might recognize high performance computing. So we're talking hundreds of thousands of computing computations, right? Of a number of cores. So simulations are, you've got simulations to consider, which are vast and large, three-dimensional rendering, modeling, and so on. These are the domains of big computing. Okay, so it's not going to be something small. It's going to be something that really you have a large boatload of information. You need to break it down. You're trying to understand the value of it, or you need to ascertain information from that big data that you collected or from that high power computing. And so it will make it easier. It's kind of like when we segment in our networks, and we're going to get to that when we get to test outs networking. I like segmentation because it makes it easier to manage. When you have something that's large, like if you had one big butt network, it's not going to be easy to manage. But if you can break it down into smaller groupings, it makes it easier for you to manage from performance, it makes the performance better, security-wise, and manageability. So it follows the same line here. So you get the idea about the data sources, your data storage, your real-time message ingestion, batch processing, stream processing, and then analyzing an analytical data store, and then spitting out the analysis and reporting. And the orchestration is all done underneath this to guide it. This all comes from Azure offers all of this. All these things that you're seeing, that's why there's such an array of information when you see it in your lab and you're thinking, it can be quite overwhelming. And as I said, it's kind of like I use Adobe, I use Creative Cloud, okay? And I don't use everything that Adobe has to offer in the Creative Cloud. I don't use Distiller. I do use the photo part, the Photoshop and things like that. I use, of course, the PDFs. I create a lot of PDFs. There's a few other things, but it offers me in the suite a lot of stuff that I'm just not going to use. So what I do is I disable them. I don't delete them. I just disable them in case I ever needed to. But disabling them protects me from having to worry about updates and anybody hacking into the system or putting a bug in there. When you don't disable things, you're leaving yourself vulnerable. If you're not using it, just disable it. That's not necessarily delete it, just disable it from the functionality of it. So again, Microsoft Azure has a lot of variety for you depending on what your needs are going to be and paying for what you need. So I have a video on that as well. So those are your Azure architectures, the different architectures that you would use. And I've given videos to give you an idea how they're applied. All right. The next thing we're going to look at is the regions and the region pairs and the geographics and the zones, because they matter. And I showed a little bit of that last night when they were talking about regions, and I gave you how many regions or countries that cloud from the different companies like Amazon and Google and Microsoft, how many they have. Well, the regions and all these things make a difference when you look at Azure. So I put this in. Microsoft reveals its massive data center, and this is a full tour. please look at these. I love going into Google, into Microsoft, into Amazon, a lot of these other ones too, other companies, Siemens, Cisco. I like looking at all these different things. So this is a massive data center that came out, I think, a couple of years ago now with Microsoft. Please watch this video. It's amazing. Now, when we talk about regions, an Azure region is considered a set of data centers, right? Because these are all data centers that are in the cloud. And they're deployed with an interval defined perimeter. Okay. And they're connected through, again, low latency networks, low latency. It gives customers the flexibility to deploy their applications where they need within a discrete pricing and service availability. So each Azure geography has its own regions that meet the specific data positions and compliance requirements. Compliance is extremely important, and we're going to get to that when we get to security as well. So there are two regions, there are two categories, recommended and alternate. The recommended regions are where you will find the most service, okay, and the availability zones. And the alternate regions, which are like the fillers, the little fillers that are in between. So think of it like your cell phone provider. When I'm driving, when I'm driving from my house to go to Lake City, which is about a 40-minute ride north of here. Used to be I only drove 5 minutes up the road to go to Santa Fe College when I taught there in UF. But they're 40 minutes north. I can be in my car. It's a nice day, even when it's a cloudy day, and it's open on what's Interstate 75. Nothing around you. I can be driving along and I'm talking, and all of a sudden the call drops. Because again, it depends where those cell towers are or anything else that could be interfering in the area. Well, with this, it's the same thing. You're going to get the services wherever they're located. And that's why you slip in these little alternate fillers to help take up those spaces that are open. Okay, so that's what the regions do. It's the same type of thing. So even when I get close to the college, and there's no rhyme or reason. There's days when I can get through on my phone, and there are days to drive up a road and I can't get through on my phone. Who knows? It's just wild, just wild. Now, when we look at the groups, how the services are grouped, okay, we know that there's two types, but how they're grouped. You're looking at the availability in the zones, right? So we've got foundational, mainstream, and specialized. Now, foundational are available in all the recommended or alternate regions within 90 days of the new foundational service becoming available. With the mainstream, it's available in all recommended regions within the 90 days of that general availability, but it's demand driven in the alternate regions. So again, the demand is the demand there. So many are already deployed into what's called a large subset of that alternate region. So you could have little subsets. And then the specialized are targeting services that are offered, say, usually industry focused or backed by a certain customized hardware that's necessary. Again, demand driven across the different regions, and many are already, again, deployed into a large subset of what's called the recommended regions. So you see here with mainstream, we're using alternate regions for demand driven, but for specialized, we're going with the recommended regions, the recommended regions. So you have to pay very close attention to this as far as foundational, mainstream, and specialized. Now, availability. We all want availability all the time, don't we? Don't we get ticked off? It's like, oh my God, I don't have availability. What am I going to do? So that's why we have what's called availability zones. So with Azure availability zones, they are unique in their physical location, right? High availability to protect your applications if you were the business owner or enterprise person, and data from data center failures, because you don't want the single point of failure like in a regular network. You don't want data failures. You've got to have a way to pick up. You've got to have somebody's got to be picking up, so that you can't just say, oh, well, I'm sorry, we don't have connectivity today. Okay. And each zone is made up of data centers that are equipped with independent power, independent cooling, and independent networking. The physical separation of these availability zones within a region is mapped out to protect data and running applications from any particular facility level issues. And then the zones provide redundant service, because remember I talk about scalability, but I also have to talk about redundancy, because you need to have a backup plan. You can't just say, okay, well, we're offering this service and you're a provider, right? Oh, well, our system went down and you took down maybe that person's business or that enterprise, which had 20 locations. That's not good. It's not going to good optic for you. That's the provider. So you have to have redundancy, and you have to have zone redundancy, which will replicate those apps and that data across the availability zones to protect from your single points of failure. Quality of service is huge. Performance is huge. So that's the purpose. And I've got this map here that shows you, okay, if you look at it closer, okay, the available region, what they're announcing that's coming, availability zones available, announced availability zones. And so you get the idea of where they're located. I mean, look at these over here, like Norway, Norway West, Norway East, that are coming. So you see where these availability zones are located, or those that are going to be coming across the globe. Now, why do they matter? They give you the flexibility of deploying your applications where you need to, including multiple regions to deliver what's called cross-region resiliency. It matters when you're moving your workload to Azure, because if you're going to move it all, and you will decide, we're going to move everything to use Azure. We're going to become Azure. We're Azure, Santa Fe's Azure, University of Florida's Azure. I don't know about Harrisburg University, but we moved everything to Azure. Right, so you need to make sure you have that availability in those regions, right? So the point being is the most important considerations are high availability, disaster recovery, and encryption, security. The availability of the Azure services across these regions provides the broadest range of services capabilities designed in order to support those availability zones. You've got your regions and your zones, right? There are over 140 countries with over 60 regions worldwide to choose from. And that means optimal performance, high availability to your business, no matter what size it is. So you see, we're talking 140 countries. That's vast. And then thinking about all the regions within those locations, you should never have a problem. If one goes down, you should be able to go to another, just like here. Here's your Azure region. We've got zone 1, we've got zone 2, we've got disaster recovery here in zone 3. So there's no reason between if zone 1 went down, you'd still have zone 2 or zone 3 available to you. That's the beauty of it. Now, I'm not trying to push Azure on anybody. It's a great tool. I mean, it really is. There's other stuff out there, but Azure's really big. But AWS has theirs, Google has theirs, and other companies do too. And I have a video on Azure architectural components, and it continues on for regions, and he explains it really well. All right, so let's now look at the final thing that I'm going to do today, and then go to your lab, is resources, because that's what we're working with right now, is the resource manager. So the resource manager provides the deployment and management of that service, of those services. It provides the layer of management that helps you to create, update, delete your resources from your account. You use the management features, just like access control, locks and tagging and securing and organizing your resources after deployment. So you're the one controlling that. You're the one controlling all of that. You decide. When you look at deployment, you're following, and this is what you see when you're going into what you're going to be working with when you look at the Azure Resource Manager. So the following image below shows you how the manager handles your Azure requests. So here's the Azure portal. That's what we've been going into. You have also PowerShell. That's Windows PowerShell, but you have an Azure PowerShell. You have an Azure command line interface where you can type it in and tell things that you want it to do with your software development kit. And then you have what's called the REST clients. So all of this leads into, you'll see the Azure portal and your clients. go immediately right here to get into the Azure Resource Manager that you're going to be controlling information. The software development comes with PowerShell. You have to use it with PowerShell or the client, the command line interface. These two, the client and the Azure portal, would not go directly to software development. This is for you to do there because you're telling it what you need for it to do. Right? You're guiding it. And then your your Azure Resource Manager access. So you authenticate to get into it. Oop, let me go back. And then you can either go to data storage, you can use your web apps, you can do your virtual machines, which you're going to do for this next lab, any type of server management or any other services that you have signed on for from Azure in order to do for your business or your enterprise. Now, I do have a video on the Azure Resource Manager and DevOps. Remember, I talked to you about DevOps. And just so you know, in case you don't know what JSON is, it's JavaScript. JavaScript object notation, which is also known as a lightweight data interchangeable or interchange format. And that's what we tend to use. You saw the file that you made over here that you saved. Let me open that. Let me pull that over. Okay. These are JSON files. These are JavaScript object notation files. And that's what we're utilizing when we're utilizing our Azure. The benefits of using a resource manager. Well, you can manage your infrastructure through what's known as declarative templates rather than having to write scripts. PowerShell, you're using a lot of scripting. You need to understand scripting, but this helps to save time. Same thing with command line interface. You're writing in directives. Deployment, management, monitoring your resources is easier as well. You can either handle it together or individually as a group. As a group or individually. You can redeploy throughout the entire development lifecycle and have confidence that your resources are deployed in always a consistent state. Defining the dependencies between your resources so that they're going out in the correct order, not other way around. Applying your access control to all the services because Azure is a role-based access control, which is integrated into the management platform. So when I'm teaching security, we talk about DAC, RBAC, mandatory access control, MAC, and so on. Pretty much everything that I've done is always role-based. It makes it easier. It used to be when I first started at UF, when they set up the computer systems and they would assign them to the areas, they actually assign them to a person's name. Like we had so many employees, at our campus. I never understood why would you assign it to a person's name. What I did was I completely changed it out and I assigned it to the department. And then within that department, you had so many folks, so many devices. And so like I'll use plant pathology for an example. So with plant pathology, we were known as IF-TREC. Okay, the University of Florida's Institute of Food and Ag Sciences. PREC, it was the campus that I was at. So all machines had IF-TREC and then dash, and I would make it PP, and I would either put it as senior faculty, senior biologist, lab personnel, like lab 1, lab 2, lab 3, and so on. That made it easier for me to know that, these are relegated to plant pathology in this department when I see PP and then I have information next to it, not the person's last name, because people come and go. You should never, ever assign it to a person, assign it to the role or something like that. Pretty much everything we do in enterprise is role-based, but just so you know, that's an example. You can apply tags to the resources so that they're locally organized. It's kind of like tags are what we utilize when we go to search on the internet. Of course, there's a lot of duplicates out there, especially, but tags are used so that when you go to a site, it pulls that index page for you. It goes and gets what you're looking for from that tag that's allocated to it. So you can put that in a logically organized way of your resources for that subscription. And you can clarify your organization's billing and by viewing the cost for that particular group of resources that are sharing that same tag. So there's a lot of benefits using the resource manager. Also, it's easier to get your reports and information to support what it is that you're doing and show your boss or the administration or whomever. Now, containers, we talked a little bit about containers. They're known as ACI, Azure Container Instances. And this is a managed service that allows you to run containers directly on the Microsoft Azure public cloud. You don't have to use virtual machines. You can just use the containers, right? So you see, here's a virtual machine with an agent. Here's a virtual machine with an agent. That could be a hypervisor. Here's the Azure container. We're accessing via the portal. And from that, using the Azure container, we can use the Azure. They're just using a service fabric, container services, OpenShift, and so on. It's whatever it's going to be that you want that container to have. And then you can monitor from that container who's accessing, where's it going, what are the needs, right? Without having to have virtual machines involved. You're just containerizing, and you can have many containers. So how do these containers actually work? Well, what they do is they process the data. Wherever that source data gets ingested or processed, and then they put it in what's known as the Azure Blob storage. Well, you saw a little bit about Blob. It was like a variety of stuff just thrown into the pot, just thrown into the pot. So by processing the data with the ACI, rather than you statically provisioning using virtual machines, you can achieve a very large cost savings through per second billing. And this video shows you more about that. So if it was my choice, I would go with containerizing that rather than using virtual machines. Okay, so I have videos in there for that. Now, the features for the Azure Container Instance supports both open source, meaning Linux and Windows, not Apple, but Linux and Windows. The ability to launch new containers, you can do it right through the portal or the command line interface. Supporting standard Docker images and the use of the public container registries or the Docker Hub, as well as the Azure Container Registry. The ability to provide access to containers over the internet using a qualified domain name, meaning qualified domain, and IP address. The ability to specify the number of computer processing unit cores and memory that's going to be required for those containers, because it's the same thing when you're doing virtual machines as well. And supporting persistent storage by mounting Azure file shares to that container. And lastly, developing groups that organize multiple containers that share the same host or same storage or same networking resources. So you have a lot more flexibility to build your puzzle and work with all of it to make everything great. For lack of, I've lost my train of thought there for a minute, sorry. Okay, well, let's look at blob storage. So blob is just a massively scalable and secure object storage from Microsoft Azure. You can have a number of things put into your blob, and I have a video for that. But if we don't always just want a blob storage and we want to containerize and put specific things, we have the capability of doing that as well in Azure. Now, Kubernetes. This is for storage and networking management. Storage and networking management. And this is, again, larger scale. We wouldn't use this for a small scale. We'd be using this in an enterprise system like we use it Florida Gateway, like I've used it UF. So you would want to have Kubernetes in your choice from Azure to utilize as a resource. And I have a video on that. And then the Azure Cosmo DB. This is extremely extensive for e-commerce, to run Windows or the Windows Store, or look at Xbox. I mean, some of you may do gaming. This is where Cosmos DB would come into play. It's used mainly for retail industry, for storing your catalog data, event sourcing, processing in your pipeline. So we're talking a very large e-commerce platform. And my examples are, again, the Windows Store or if you went to a Play Store or something like that, or Xbox Live in real time. And I have a video on that as well. Okay, I think that's getting down to Azure SQL and NoSQL. So we talked a little bit about that yesterday. Again, a SQL database is known as platform as a service, right? It's just a full managed platform. And it has your database engine that handles most of all the database management functions, such as upgrading, patching, backups, and monitoring without having to have any user involvement. So we use SQL because that's our querying language, right? Our SQL querying language. And the database is relational. So when we look at this for Azure SQL and Azure SQL Managed Instance, they both run the latest version of the SQL database engine and the Windows operating system. So now we're still Windows 10, but we're all in Windows 11. And when setting up the SQL Managed Instance in Azure, you're setting up what is known as the Service Fabric Virtual Cluster. Service Fabric Virtual Cluster, which will then take over for the management of that instance. It takes over for you. So new deployment option that enables frictionless migration for your SQL apps, modernizing a fully managed system. So here's your database. You can have your managed instant. You can do it singularly or have an elastic pool. It's called an easy lift and shift, fully managed by your platform as a service, full isolation and security. And I'm going to be getting into VNet next Tuesday, and new business model. So you see it's a full-fledged SQL instance with nearly 100% compatibility with your on-prem, which you have on premises. It's built on the same platform as a service infrastructure. It has all the same features as platform as a service. It has what's called native virtual network, private IP addressing, just like we have private IP addressing in our enterprise systems. It's not public. Just like at your home, you have private IP addressing for your devices that you're using there, and your public facing is your internet service provider. And then with the new business model, it gives you competitive edge, transparency, and it's frictionless or seamless. Now the NoSQL doesn't have to do all that. You don't have any SQL aligned here. So how does that work? And I have a video, so make sure you watch that. With the NoSQL databases, their database is based on what's known as data models or other than a relational database table. So the four most common types of NoSQL are key value. This means that the key value stores pairs keys and values using what's known as a hash table. When we look at document, it documents the databases. They extend the concept of that key value database by organizing the entire documents into groups that are called collections instead of a relational database. And they're columnar, and they use graphs. So when you look at this, you'll see here's our Azure Active Directory, our Azure Security Center. We've got our Azure infrastructure connecting to the internet, our virtual network. We have our on-premise data center, right, using SQL Server. And we are now going to use the Azure SQL Data Sync and the Azure Data Migration Services. And so what we do is we can go down, because if you're going to do these two, you see you get your managed, your warehouse, your open sources here from MariaDB, MySQL, database, PostRage, virtual machines, Elastic Pool, single. But if you go from here, your on-site premise, to NoSQL, you can just go to NoSQL and to your data factory this way. And from the data factory, you can go into what would be considered SQL. I know it's kind of like, okay, this is a lot for my head to absorb. But this gives you an idea. They're not using relational databases. They're using other models of data to do that, using key values documents in order to do that. So it's a different type of databasing. But I do have the video on NoSQL databases to explain it further. All right, so I think we finished that. So when we come back, we're going to start with the core solutions and management tools. That down so I don't forget. The core solutions. That'll be on Tuesday. And we'll get into VNet. Okay, so for now, I'm going to go ahead and go to the lab. So we're going to deploy an Azure virtual machine. And I already went through this once, so hopefully I won't have any problem like yesterday. So I'm going to open the lab window. It's going to build it. And remember, always look at your resources first. So I've already logged in. I think this is still the same one, but when you look at your resources, it's different than the one last night. So you just copy from the clipboard, That's the 161. Did I save it? No, I didn't. All right, so I'm going to copy this from the clipboard. I'm going to use another account. I'm going to log in. Now I'm going to go get the password and cut and paste that in. Copy, paste it in. And now I'm going to get into the lab. So then just go back to your instructions and follow your instructions. It's always going to ask you if you want to do the tour. So we've got that set up now. Follow the instructions exactly. All right. So, and again, as I tell you, always expand because it's going to make your life so much easier, especially because you only have so much time. So what they want us to do is we're learning to use a virtual machine in Azure, right? Just down and dirty. So you're going to go to your portal page. This is our portal, and click on virtual machines. Right? Okay. And what they want us to do is they want us to add a machine, a virtual machine, right? So we go to, it says add, but it's really create. So please don't get confused by that. When you look, because you're looking for add, it means create. And just click on create and go to Azure Virtual Machine. And when you do, it will start to create the virtual machine. And this is what you should see. And it will have, this is already set up via through NewPass, the account. So you say, okay, I've done that. Now you want to create on that virtual machine blade this resource group. So you'll see, resource group. All right, so there's your resource group. Now I've already done this. So you're going to have to copy that and paste it in, unless it's there. So I click on that. And now you'll see the instance details. So I need to go to where it says region. And we want to make sure that we've chosen the correct region. Now, I've done this already, so you're not going to see region 2 until you do it. So click on region 2, so you choose it. And then what you need to do then is we've got our availability zone. It's going to be zone 1 because we're not changing anything there. And what you want to go down to is where it says image. And image, it says this is an Ubuntu server. Well, we don't want Ubuntu. We want Windows 2019, right? So we click on the Windows Server 2019 data center, right? Because there it is. And then in size, we want to change the size. So we need to change the size. And in that, we change the size to what it says DS3 version 2. So we go to standard, where is it? See all sizes. All right. DS3 version 2. Okay. So we select it. And now it should come up with what we need. So it's telling us that's going to be about $341.64 a month. Right. So it gives you your money there, right there. It tells you what you can be charged. All right. And then we want to select, and then we want to put in the username. So copy that. The username is AZ900admin. Paste that. And then we want to put in the password. Paste that. And then we want to confirm it. Paste it again. And now we're pretty much done. We review and create. So we review and create. It's creating our virtual machine for us. Do you know how simple this is? All right, maybe because I already did it once. Did I miss something? I don't think I missed something. Missing information. So let's go back. I don't think I'm missing anything. I think I did it all. Done it once already. Create. I think because I already put it in once. I'm sorry. I walked through to do it just to make sure. When you start off, it should be, we want to change. I forgot to change the name to Virtual Machine 1. Okay, so let me go back to home. Sorry about that. I'm going to get with it, guys. I promise. Let me see our screen. This should be VM1. All right, and just follow the same instructions I just gave you. All right. DS3, version 2, select. the username, and then the password. And we'll have to put it in twice. Okay, I think I got it all in. Review and create. There we go. Sorry about that. So review and create. All right, and it tells you that the validation has passed, and it says for you to make sure that it has, and it did. So we've got that done, right? And then we've created it. And now we're going to submit the deployment of it. All right, then the next thing you do is click on next. All right, so we see we want to view the properties because we've created it. Now we need to view the properties. So what we need to do is we need to go to the overview, right, for that machine. So you have to go into your search. Actually, I can just go right here. Let's type into it. Okay, go back to home. Go to home. I need to read. Sorry, guys. Home. So you want to go to your home page and hit on VM2, just like it says here. And here's your overview. So sorry about that. I'm trying to concentrate, guys. I'm really sorry. Yeah, so you can go to the home page, look at your virtual machine number 2. Here's your overview, right? And you're confirming that we've checked our work. So there's our resource group that it's running, East US 2, the challenge 5, subscription ID, the display name is VM2. This is our public IP address for this virtual machine. We are using the standard DS3 Windows, and it should be Windows Server 2019. I'm pretty sure I've picked that, and so yes, this is what you should see once you're done and you've created it, and then go to the home page to double check it, and you confirm your work, and then go to the summary, and you end. And then yes, end my lab. Okay. Now, if you have any questions or problems, please let me know, but you shouldn't. But I've walked you through. So now you should be ready to go to have your work done for Saturday. Okay. And I will be around. I'm going to be with my family. So you guys take care. Have a good weekend. And I'm going to get this ready to post.